Hello everyone and welcome to another video. Let's continue making our programming language, should we? Just gonna open up my editor here. So, in the previous video we were working on the parser, which is the second step in the whole process. As you remember, first the lexer gets the source code contents as a string, and then the lexer gives tokens to the parser, and the parser creates an abstract syntax tree. So that was what we were doing in the previous video. We were working on this abstract syntax tree creation stuff. I'm probably gonna make my cam a bit smaller actually, because it's a little bit in the way. That'll do. So I think that we were actually yeah, let's look at the our code here that we were trying to parse. Right, so we're reaching I remember that we were printing the root type, and that was a compound, and then we printed a compound size, and now we're actually expecting the compound size to be the size of 2 because we have 2 statements, but we're only getting I think we're only getting 1 right now. Yeah, so we're only getting 1, the size of 1. And I think that was because, let's see here. Oh, I need to recompile to remove that message. So I think that was because the parser don't know how to parse the function call yet, basically. So we need to do that. And we are doing that when we're parsing the variable. Then first we're expecting an ID, and then if the next token is a left parentheses, then we just assume that it's a function call. So we are ending up here right now, I think. Func call. Yeah. So now we need to tell the parser how to parse that function call. So now the function call needs to know the name of the function, basically. Because if you look in our AST node here, or the AST struct, we can see that we have a string function call name. So we need to store that somehow. Now, the way I have done this before is we want to store this one, basically, and give that to the function call. Now, a very simple way to fix that, or to solve that, is to, in the parser.h, in our parser state here, we're going to add another token, previous token. I'm going to go into the parser.c, and I'm going to do parser prev token is equal to parser current token. We're just going to make it start with that. And then when we expect a token, and we go to the next token, we're going to save the current token in the previous token. So parser prev token is equal to parser current token. Cool, so now we will keep track of the previous token. So now in our function call, let's just see if we can print the function call name. So printf func name parser prev token value. And that works. The function name is print, which is correct, right? We're trying to call the print function. Cool. So now we have that. So now we can start creating our AST node for the function call. So ASTT function call is equal to init AST AST function call. Okay, and then we want to store the function call name on that. So function call call name is equal to parser prev token value. Cool. Now we have some other stuff that we need to store as well. We have the function call arguments and the argument size. So what we can do is we're going to copy the thing we did in the parse statements, because we're doing a similar thing here. We're doing, while we have a token semi, we keep parsing statements and we add them to a list. And that's the same sort of idea that we're going to do for the function call arguments as well. But instead of using a semi, we're going to use a comma. So I'm just going to copy this. I think, actually, let's copy almost the whole thing, and then we're going to go back to the parse function call. Now, instead of compound value, we're going to do function call arguments. So we're allocating memory for the function call arguments that we see here. And then what we're going to do is we're going to parse expressions, because the function every argument here is going to be an expression, basically. Kind of. Not really, but oh well, yeah, they're kind of expressions. So yeah, every argument here is going to be an expression. My brain had to work a little bit there. Okay, so back to parse function call. We allocated memory for the list, and now we're going to do AST. We're going to keep parsing expressions. So, and we're going to add that first expression to the list function call arguments. So we're adding that to the first pointer in the list, because because we don't have any other place to store it. And then we do AST expression, and we're gonna switch this function to parser parse expression. And I think you can already see what's gonna happen here. Like, we're gonna parse the function call, and then we're gonna parse an expression which goes to here. And this one knows how to parse a string, and you know we're well, actually, this is this is kind of wrong, actually. Parse statement. Yeah, it's not really going to work exactly how we want it to do, work. But let's just do this first, and then we'll fix it. I noticed some small issues here, but anyway, this is correct. Okay. So parse expression, and we're adding the expression to the first index in the list, and then we're going to do while parser current token type is equal to token comma. I wonder if we even have comma. Token. No, we don't even know. We don't even have comma. So we need to parse comma as well. So token comma. So we're adding the token comma to the token.h enum type here. And then we actually need to tell the lexer how to parse a comma as well. So we're going to do, in our little switch statement here, we're just going to copy one of these. In the lexer get next token function, we're going to copy one of these cases, and we're going to add one for comma. And then we're going to switch out the token rparent to token comma. And that should be all. Let's just recompile real quick. Yeah, we're gonna get an error there because we have some error in the parsing code. We didn't finish it. Okay, so we're parsing comma, or we're looping while we have comma. Parse each token comma. We're still in the parse function call function. Remember that. And then we're gonna keep doing the same thing that we're doing here, basically, like that. And we can remove that, and then we're gonna replace compound with function call and compound size with function call arguments size, and we're gonna replace compound value with function call arguments, and we're gonna, I forgot to replace this one as well, function call arguments. Okay, and this one should be AST expression, and that's basically it, isn't it? So yeah, what we're doing here is that while we have a comma, we parse expressions, and then we increment the argument size by 1. Then we add the expression that we then we're first reallocating the memory for the arguments list so that we can fit a new expression. And then we're adding that expression to the last index in the list. Cool. And it still doesn't compile because we have a compound here and it's wrong. It should be function call. Because this is this AST node, remember? Compile. Cool, so that compiles. And now we're going to return the function call node. I wonder what happens if we run our program now. We're still not getting everything. And I think this is because now we're gonna parse expressions and it won't know how to it doesn't know what to do with because it's gonna get a an ID in here. If we print, I think we're gonna end up here actually. So if we do, I think we're gonna end up here. So printf, and we're gonna print the parser current token type. Looks like that. I think I have forgotten one thing, didn't I? I forgot to expect the left parentheses, which is gonna cause problems actually. So what I need to do is we need to do parser eat parser token lparen, and then after our while loop here, we're gonna eat the closing parentheses. So parser eat parser token rparen. Unexpected token name, right? Because it doesn't know what that is. Because we're going to expression and we're getting the type 0, and the type 0 is what? How can that be? That actually doesn't make sense with type 0. So it's getting a variable definition? What? That's pretty crazy. So parse variable definition, parse variable. I really wonder why it's getting a variable definition. That's pretty weird. Parse expression. just have to make sure it's equal to AST or token label definition. Whoa, that's wrong. No. Oh, I was looking at the wrong. It's not a variable definition. We're getting the token type, token ID. So that is what I expected. So I guess one quick hack for this is to copy the case token ID from the parse statement function. I mean, it's sort of correct. So what we're gonna do is that we're just gonna put that in here as well, and that's gonna make it work. If we remove this. And we're getting a segmentation fault actually, so that's pretty funny. Why are we getting a segmentation fault? Parser parse statement, line 41. Parse statement. Statements 59. Semi. Why is that happening? That's pretty weird. Parse expression. Oh, I think we're actually reaching the end and we're getting like a void. I think we're actually getting a void or a null token actually. So if we look at the line 41, let's just do printf. Let's print a pointer, parser current token. Yeah, we're getting a null pointer, that's why. So one way I like to fix this is to add in our token.h. We're gonna add another token called token end of file, and I think that's what we want to do. Parse statement. Yeah. So we're going to add an end of file to the token.h, and then in our lexer.c, instead of returning void here, we're actually going to return that token. So return init token token end of file, and we're just going to add an empty string like that. And we recompile the whole thing. And now it's working. And now we actually are getting a compound value with a size of 2, because we're printing that here. So now we got all the stuff we need actually. So now we can actually start writing the visitor, I think. I think we have implemented most of the stuff that we need to be able to do that part. Now we haven't got into doing the factor and term stuff. We actually won't need to do that right now in order to get our simple program to work. So I'm thinking we're gonna skip that for now, and we'll do that in another video. I just want to make our little program to be able to work or to run, and then we'll add more math stuff and yeah, other cool stuff later. So now I want to show you how we can start writing the actual runtime or the visitor to make our code do stuff, right? Because it's not really doing anything now. Let's remove our, where I think I have some print statements here, right? Let's just remove the print statements. Cool. So now what we want to do, we're going to start writing the visitor, okay? So the first thing we want to do is to create a visitor.h, And then we're going to do if not defined visitor age, define visitor age, and if. Now, if you remember, the visitor takes the abstract syntax tree that the parser has created, and it's going to visit every node recursively and perform operations based on what kind of node type we're ending up on. Okay, so what we want to do here is we're going to have a state for this as well. Actually, we won't need a state right now, I think. We're going to ignore the state for now. We'll see if we need it later. But we're going to define some methods in here. So we need to include ast.age, and we're going to define one main entry point method called visit or visitor visit. So, and every method here is going to return an AST node. So AST visitor visit, and it's going to take in an AST node. Okay, and then we're going to have separate visits method for each type that we have. So if we go in here, let's just copy the types that we have here. Whoops. And put them here so that we can easily copy them. So we're going to have an AST visitor visit variable definition, AST node, AST visitor visit variable, AST node, AST visitor visit string, AST node, AST visitor visit compound, AST node. So that's all that we're going to need for now. So let me tell you a little bit about this. So the visitor visit function is going to take in the root node, okay? Then it's going to look up what kind of type it is, and it's going to call the appropriate child method to visit it. So in our case, we are first going to encounter a compound node, which is the entire source code. So we will go here, then we're going to loop through the compound children, and the first children we're going to encounter is a variable definition. So then we're going to call this function, and this function is probably going to store some information about that variable in our memory so that we can access it later. Okay, and then it's going to go to the next iteration in the loop, and we're going to encounter this node here, which is the type of function call. Did I forget to add that? What? Yeah, apparently I forgot to add it. I'm just going to add it. It was underneath the variable. So AST visitor visit function call, AST node. Okay, so we went to the compound, we iterated through the definition, we iterated through the children, we encountered this one, and then the last children or child that we're going to encounter is the function call. So we're going to encounter the function call, and this one will try to call that function. And what calling a function means is however we define it in our code here, okay? So we're going to have to define a built-in print method later. And the function call is going to call this visit function on every argument that we give it. So it's going to visit this node here. And I guess you can sort of guess what's going to happen. It's going to look up in the memory what this is, because it's going to know that it's a variable. So it's going to go and visit the variable. So in our visit variable method, we're going to have some sort of memory reading code that's going to look up this variable name, and it's going to find this definition, and it's going to return the value of it basically, which will make it print John Doe. So I think this is all for this video. We have started to define the function definitions for the visitor in the visitor.h file, and we're gonna implement those in the next video, because I think it's gonna be a very long video otherwise. But we're almost there actually. I think in the next video we're gonna be able to run our program, our little hello program here. So yeah, and we also fixed some stuff in the parser, so that works good now. And in some video we're also gonna implement these. These are sort of only necessary if you want to be able to do math and stuff. But so yeah, we obviously we want our programming language to be able to do math. So we're gonna implement those in another video. But yeah, we'll have our code running in no time at all. I can almost guarantee you that in the next video we're gonna be able to run this code. So thank you so much for watching. If you're not already subscribing, please hit the subscribe button. And if you don't want to miss any videos, also hit the bell button. And until the next time, I hope you will have a wonderful day or a wonderful evening or a wonderful night or whatever. So thank you for watching. I appreciate it. And I'll see you next time.